Good morning, 7th grade. I hope you are well and that you are washing your hands and staying home as much as possible. Mr. Hale here. I want to continue our review of probability. Today, specifically, I want to talk about complex independent probability, also known as compound probability. And as a reminder, compound or complex probability is the chance of multiple things happening in a sequence. So yesterday's work on simple probability was one thing happening. This is all about many things happening. And though it doesn't say that on the paper you can see on your screen, I mentioned the word independent. An independent probability means what happened before does not affect what is happening next. The other term you may have seen for this is replacement. Independent probability is also known as with replacement. So for example, in number 1, after we pull the white marble out of the bag, we put it back in the bag before we pull out our second marble. And then we put that back in the bag before we pull out our third marble. So each of the 3 draws, the probabilities remain the same. Each time there are 60 marbles broken down into these colors. We'll talk more about dependent probability without replacement tomorrow. But for today, it's independent. So every time we pull out a marble, we're going to replace it, put it back in the bag. Okay, let's look at number 1. We want the probability, that's what the P stands for, of getting the exact sequence, white, and then blue, and then red, as a fraction. So let's go down here, pull up a red pen, and let's go here. See, so number 1. All right, so first thing we need to know is that since we are doing replacement, every time we make each of these 3 pulls, the denominator is going to be the same. The first time we pull a marble out and get a white, we'll have 60 marbles in the bag. And the second time we pull a marble out, and this time we want to get a blue, there will be 60 marbles in the bag. And the third time we want to pull a marble out and get a red, there's still 60 marbles, because every time we put the marble back in. Let's find our numerators then. The first thing we want is white. How many of these are white? Well, it says 12 of them are white. So we put a 12 here. Second, we want to get a blue. How many are blue? 6. So we put a 6 on top for the second draw. And then the third is red. How many are red? 10. Put a 10 on top for the third draw. So white is 12, blue is 6, red is 10. Once we have written down each individual probability, then we need to multiply them together to get our total compound probability. But wait, these can be simplified, it looks like. 12 over 60, because if we multiplied right now, we would get an accurate answer, but it would be a very, very big set of numbers. If we can simplify these fractions before we multiply, our multiplication is going to be much easier. So, the first one is 12 out of 60. That becomes 1/5. The second one is 6 out of 60. That's going to be 1/10. And the third one is going to be 10 out of 60. That becomes 1/6. And now we can multiply. 1 times 1 times 1 across is 1. And 5 times 10 is 50, times 6 is 300. So the probability of getting the exact sequence, white, and then blue, and then red, is 1 out of 300. We wrote down each individual probability. White was 12/60ths, blue was 6/60ths, red was 10/60ths. We simplified, we multiplied. There's our answer. All right, number 2. Same process here. Let's get a different color. Let's go to orange. We want the probability of green and then black as a percentage. All right, so let's write down here number 2. Okay, first thing we got to write down is the probability of green. Well, we know the denominator is going to be 60. How many of them are green? 5. 5 of them are green. We write 5 out of 60. Once we pull that green out, we put it back into the cup, we replace it, and now we have 60 marbles for our second draw, and we need to pull out a black. How many of them are black? 15 of the marbles are black. So we have 15 on top. Already wrote my multiplication symbol, but wait, we got to check if these can be simplified. 5 out of 60, can that be simplified? Yes, those are both divisible by 5. 5 divided by 5 is 1. 60 divided by 5 is 12. What's 15 divided by 60? That simplifies down to 1/4. So now we have our simplification. We can multiply. 1 times 1 across the top. 12 times 4 across the bottom. Our probability of getting green and then black in that order is 1/48. But wait, we want this as a percentage. So we're going to put a fraction over here with 100 on the bottom. And then think back to 6th grade. How do we solve for a percentage like this? We're going to multiply our diagonals. So 100 multiplied by 1, that's 100. And then we're going to divide by 48. (100) divided by 48 gives me 2.08%. If you want to use a calculator to do that calculation, by all means do so. All right, number 3. We want the odds this time, and specifically we want the odds of going yellow, then white. All right, so boom. So first thing I'm going to figure, first of all, we know that both the denominators are going to be 60. So we know we're going to multiply, so we can set that up. What is the probability of getting a yellow? That's 2. What's the probability of getting a white? That is 12. Sorry, I couldn't find it there for a second. All right, now, let's simplify if we can. Switch colors, because that's what we've been doing. Let's go to teal. 2 out of 60 can both be divided by 2. That gives us 1/30th. And then 12 out of 60, we saw this up here. That simplifies down to 1/5. Now we multiply. 1 times 1 gives us 1. 30 times 5 gives us 150. But wait, we want to turn this into odds. We want to turn this into odds. So remember, we have a ratio, so colon in the middle. We want losers on the left and winners on the right. How many ways are there to win? Well, that's our numerator. There's one way to win. So how many losers are there? Well, there's 150 ways to lose. Sorry, there's 150 total possibilities. One of them is a winner. That means all the rest are losers. 150 minus 1 is 149. So the odds of pulling the exact sequence yellow and then white with replacement is 149 to 1. Okay, I'm going to leave this video there for now. Take a look at your homework packet for another short assignment, this time about compound probability. We are going to talk about situations like number 5 and number 6 later in the week. Those are situations where it's a compound probability, but you may not be able to figure it out by multiplying. Maybe you can, but sometimes you can't, or sometimes it's easier to do without multiplication. We'll get there later in the week as part of our review. Remember, that test that was in your paper packet, I am more than happy to let you guys have another crack at it later on. So if you didn't do too well on your first assignment or first time through, that's fine. I'm going to make sure that you guys get the best grade I can possibly give you. Do your best. Stay safe, stay home, wash your hands, and I hope I'll see you soon.